Hello guys, welcome to the next part of the authentication wherein we will be studying what is the message authentication code. In the previous lectures we have seen what are the authentication requirements, what are the authentication functions. Also we saw what are the different types of authentications which can be used to prove the identity of the users, and now we will be studying a new concept, that is the message authentication code, which is then appended with the message to prove its identity, to prove the user's identity. So let's begin with it. Message authentication code, it was generated by an algorithm that creates small fixed size block, and this fixed size block is dependent upon two things, that is both the message and the secret key. Depending upon what secret key is being used and what message is being used, a small fixed size block is generated, and it is being generated with the help of the algorithm. Like encryption, there is no need to be reversed. Like for the decryption, we then reverse the process of encryption to get the plain text back. That is not used in the message authentication code. It is appended to message as a signature. Receiver performs same computation on message and checks it whether matches the message authentication code or not. That means at the receiver's end, it verifies the message authentication code to check the user's authenticity. Provides the assurance that the message has been received unaltered and has been received from the authenticated sender itself. So this is just the basic diagram of the message authentication code, wherein we can see that a message capital M, that is a plain text message, is then appended with a MAC function that is created by using a key, and then it is XORed with the plain text message. It is appended with the plain text message. Then when it is being received at the receiver's end, that is, it is received at the destination, it then compares that message authentication code. How it compares, we will see in detail with the different algorithms. So message is generated from the message authentication code is generated from the message plus the secret key, which can be equated as MAC is equals to C of K comma N, and then it is appended to the message, which is then sent over the network for the destination user. So as shown, the MAC provides authentication, can also use for secrecy, can be used for the encryption. Generally it uses separate keys for each. Can compute MAC either before or after encryption. We can compute, or we can ensure, or we can check the message authentication code either by before encryption or after encryption, and is generally regarded as better than before, but see the generic composition. Now we will be seeing why to use MAC, why there is a need to use message authentication code. Because sometimes only authentication is needed, sometimes there is a need of authentication which needs to be persist for longer period of time, which needs to be persist for longer than the encryption process. Also, we have to note that MAC is not a digital signature, but it is dependent, it is then appended with the original message to provide some sort of security with the encryption of the plain text, and it is not considered as the digital signature. It also does not provide non-repudiation, which checks for the denying of the sending or the receiving of the messages by either of the ends. MAC is a cryptographic checksum, which is equated as MAC is equals to k to the c to the base k of plain text message m. It condenses a variable length message m. It condenses, that means it then improves the variable, it then improves the length of the message by condensing its, the cryptographic functionality. It uses a secret key for that, and then it gives you a fixed size authenticator, which then provides the authenticity, which then provides the identity of the sender. Obviously is a many to one function. Potentially many messages have same message authentication code, but finding these needs to be very difficult because we cannot easily find the message authentication code, because though the message authentication codes are same, but the process, but the key can be the different, the plain text message will be different, so it is obviously very difficult to find these message authentication codes. What are the different requirements for MAC? Taking into account the types of the attacks, MAC need to satisfy the following. The first one is knowing a message and the message authentication code is infeasible to find another message with the same MAC. As I just told you that it is very infeasible, it is very difficult to find the message authentication codes, because every time, though the message authentication code is same, but every time we will not be having the same message, we will not be having the same key. So it is infeasible to find another message with the same MAC. MACs should be uniformly distributed. MAC should depend equally on all bits of the messages. How does the security of MAC gives us? Like that of the block ciphers have. Block ciphers do have the vulnerability for the brute force type of the attacks. So here, security of MAC should provide the brute force attacks exploiting, wherein strong collision resistance it should have, that should have the hash functions which it costs 2 to the power of m by 2. 128-bit hash looks vulnerable, 160-bit is a better. This is the size of the hash blocks. MACs with known message with MAC pairs can either attack key space or the MAC. At least 128-bit MAC is needed for security purpose. That means for providing the block ciphers, or for providing the security against brute force type of exploiting attacks, we should have at least 128-bit of MAC, which is needed for improving the security of your message. Cryptanalytic attacks can exploit the structures, like block ciphers want the brute force attacks to be best alternative. More variety of MACs, so harder to generalize about cryptanalysis. We all know what the concept of cryptanalysis is. So more variety in the message authentication code will then lead to, you know um, it then leads to difficulty wise. You cannot have the idea of what the MAC is all about. It becomes very harder, it becomes very difficult for the attacker, it becomes very difficult, infeasible for the intruder to guess what the MAC can be, and then you can easily avoid the cryptanalysis type of the attacks. Keyed hash functions as the MACs want a MAC based on the hash function, because hash functions are generally faster. Crypto hash functions code is widely available. It is easily available. You can easily have that crypto hash functions, which can be then implemented to enhance the security of your message. Hash includes a key along with the message. Original proposal is like this: keyed hash is equals to hash which is being implemented, that is the hash functionality is being implemented on the key and the message. Some weaknesses were obviously found with this, that is eventually lead to the development of secured MAC, that is hashed MAC function. And now we'll see what is the problem with the keyed hash. Keyed hash that is achieved by implementing the hash functionality on the key along with the message. Just recall the hash functions works on the block. We have the block ciphers. Let's suppose M is the plain text message, key, message, message padding, and M. So M is then calculated as the combinations of M, M1, M2, M2 till the ML, where MI is the block size, H is the hash functionalities to be implemented upon the different number of the blocks of the plain text. So sometimes it becomes very problematic to properly have the keyed hash functions, and it sometimes becomes the problems to properly implement the hash functionalities on the plain text messages, but can add with the extra blocks by adding ml plus 1, which is considered as the extra block of the plain text message. And then we can implement hash dash by using the hash on the hash of the added block of the plain text message. So if there is a problem with the keyed hash function, then it can be reduced to some extent by using the hash dash, which can be then implemented on the hashed messages. Unless formatting prevents it, exactly, unless formatting prevents this addition of the extra block, we can have we can resolve this problem to some extent, but then also it becomes somewhat difficult. So it is better to use HMAC instead of MAC. Thank you guys. I just hope that you might have understood the concept, the basic concept of message authentication codes. In the next lectures, we'll be seeing HMAC, we'll be seeing CMAC, which will then again help you to learn to get the concept of why the message authentication codes are then used, why the hashed functions are then used to provide or to enhance the security of your encrypted messages. Thank you once again.